Welcome to Mickey Techie. Learn as engineer and teach as champion. First of all, I would like to thank my family for their continuous support and encouragement for creating these kinds of technical videos in a public domain. And next, I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, to ignite me for creating these kinds of technical videos in the public domain. And I would like to thank Almighty for my good health, and my friends, followers, and my dear students and subscribers for their continuous support. And today's topic of the interest is gears and gear drive. First of all, I would like to give an example of gear and gear drive. Gears are used for transmitting power of a one shaft from one shaft to another shaft with the shortest distance the power can be transmitted, and this is the application in all our automobiles. Or without gear there is no automobile. So that is the thing we can say. In all our automobile, gears are plays a vital role for multiplying the speed as well as the torque as per the requirement. Not only in the automobile, in wherever the application we want to step up or step down the speed or step up or step down the torque, we can use gear drive. But only condition is the shaft distance should be shorter. And these gear drives are positive drives. That means there is no slip occurs. Therefore, there are two positive drives which we have gone through. One is a gear drive, then another one is a chain drive. The chain drive is used for medium and long distance of the shafts, whereas the gears are used for shorter distance of the shafts. Okay, let me explain the terminologies of the gear. Here is the terminology. The important terminologies are pitch circle, pitch circle, so this is the one first, pitch circle and circular pitch. Module is there. Module is the very important thing. Addendum, dedendum, working depth, hole depth, top land, and face width, and the next face, flank, fillet, clearance, tooth thickness, and the width of the space, addendum circle, dedendum circle. These are all the important terminologies available in the gears. And the gear profiles are mostly either in the form of an involute or in the form of a cycloid. The problem, the advantages and disadvantages of the involute and cycloid will be discussed in forthcoming slides. The next one is the gear train. The gear train is when we say this is a simple gear train when the shaft 1 and shaft 2 and shaft 3, this shaft 1 and shaft 2 are called as a simple gear train because the shaft 2, if the shaft 1 is the driver, the shaft 2 is the driven, therefore it is a simple gear train. When the shaft 1 is rotating in a clockwise, the shaft 2 rotates in an anti-clockwise direction. So this is a simple gear train. When we say it as a compound gear train, we consider all the three shafts. There is a gear of say 1, 2, 3 and 4. The gear 2 and 3 are coupled in the same shaft, so it is compounded, okay, compounded. Therefore, the gear 1 rotates in a clockwise direction, gear 2 and gear 3 are rotating in the anti-clockwise direction, and gear 4 is rotating in a clockwise direction. Therefore, so this type of a gear train is called as a compounded gear train. where the input and output are in the same direction. In simple gear train also we can make as a common as like a driver and driver are in the same direction by means of a single idler pulley. Instead of this thing, if the gear is mounted here, let me consider this is an idler pulley, idler gear. Then this is in the clockwise direction, this is in anti-clockwise direction. Again, the gear 4 is in the clockwise direction. So that is the simple gear train. For your information, whenever there is an even number of gears are mounted or made as a gear train, there the input and output shafts are in the opposite direction. When there is an odd number of gears, for a simple, I'm saying for this simple gear train, if there is an odd number of gears, there should be the driver and driven are in the same direction. Okay, so let you give an introduction about the gear drive. As I said earlier, a gear drive is a positive drive. Why it is positive drive? There is no slip is occurs, and the shorter distance between driver and driven can be used. The in the gear drive, the distance of the driver and driven should be shorter enough. Okay, and the next one is the types of a gears: internal gear and external gear. In external gear, driver and driven are in the opposite direction, whereas the internal gears, driver and driven are in the same direction. Next, we will discuss the classification of the gear wheels. First of all, according to the position of shaft, first one is parallel, intersecting, non-intersecting, non-parallel. Let you explain what all the types of gears will come across these three classification, that is parallel, intersecting, non-intersecting, non-parallel. Okay, first it is a spur gear. Spur gear is for two parallel and coplanar shafts. Two parallel and coplanar shaft. What is meant by a coplanar? It is having a same plane, that is the meaning. Both shafts are having in the same plane. So two parallel and coplanar shafts, the spur gear is used. And here the very important thing is the tooth are parallel to the axis of the wheel. That is the very important. Whereas in the helical gear is also used for, can be used for two parallel and coplanar shafts where the tooth are inclined to the axis of the wheel. So that is called as a single helix. So in the single helix, the axial thrust is there. Therefore, in order to suppress the axial thrust, the bearings, needle bearing can be used. For the double helix, or we can call it as a herringbone gear, there is no axial thrust or zero axial thrust gears are there. Here in the herringbone gear, say I would like to draw the helix and herringbone. So for your example, so if consider this is a helical gear, the herringbone gear is a double helical gear. That means one helix in one side, the another helix in the opposite side. Therefore, the right and left hand helix are merged together for the double helical gear. Therefore, here there is zero axial thrust. Next one is the bevel gear. Bevel gears are used for two non-parallel and intersecting shafts. All our automobile differentials are using these bevel gears. If we have a, gear drive in this direction, so this is the just an example of a bevel gear. So if we want to transmit power in 90-degree direction, there we can use bevel gears. Two non-parallel but intersecting but coplanar shafts can be connected by means of this gear. It is used for angular power transmission also. The shape is the frustrum of cone. As I drawn, the shape is, it is like a frustrum of cone. We can make this projection, it will become a cone. Here the gear profiles are make gear profiles are made. Okay, next is the skew skew gear or spiral gear. Skew or spiral gear, it is used for non-intersecting non-parallel shafts. That is, coplanar shafts can be connected by means of this gear. This is also called as a curved gear. Skew gear, spiral gear, or curved gear. Next one is the worm and worm wheel. The worm and worm wheel having a greater advantage of high velocity ratio. Even very high velocity ratio. For your example, if our input shaft is driving in a 1440 rpm, if we want to reduce it in a say 100 rpm or 200 rpm in a single stage, we can use worm and worm wheel. It is a better it is better having a velocity ratio, high velocity ratio gears. It is also a non-parallel and non-intersecting gears. Now, here the important point is the number of starts. In the worm and worm wheel, the number of starts is increased, the effort will get reduced. That this is the condition. If we say only one teeth is contact between the worm and worm wheel, we can say it requires a huge effort. If it is having two or three worm wheels or worm tooths are connected, we can say the effort can be very much reduced. Next classification, according to the peripheral speed, there is a low velocity and high velocity and medium velocity. In terms of velocity, low velocity gears are having a speed velocity which is less than 3 meter per second. If we say medium velocity gear drive, the speed velocity ratio is 3 to 5 meter per second. There is a high velocity ratio gears, the velocity ratio should be more than 15 meter per second. So that is the understanding. Next, according to the type of gearing, one is internal gearing, external gearing, and rack and pinion. In external gearing, gears are meshed externally with each other. Say this is the driver and this one is the driven. Both are meshed externally. So this is called as an external gears. If there is an internal gear, so this is the driver wheel, so this is the driven wheel, though both are internally coupled, so this is called as a internal gear. If there is a rack and pinion, so this is the pinion and this is the rack, both are coupled by means of a tooth, so it is called as a rack and pinion. So these are all the type of gearings available. First we are going to discuss about the external gearing. Yes, the external gears are meshed externally each other. Large wheel is called as a spur wheel and the small wheel is called as a pinion. So here the terminologies are important. In the internal gearing, the gears of two shafts are meshed internally. Yes, I drew. Here, the large wheel is called as an annular wheel, where the small wheel is called as a pinion. Where the rack and pinion, here the rack is having a very important point. You have to note this. Rack having an infinite radius. That is why it is in the horizontal or a vertical position. It is in a straight line. What is meant by a straight line? The straight line is also called as an infinite radius. There is no radius for that. The radius is infinity. So it is a straight line gear and the pinion is the circular wheel. This rack and pinion is used to convert rotary motion into linear motion or linear motion into rotary motion. The example of the rack and pinion are available in the planar machine. Planar machine, your automobile steerings and footstep bearings, all over the rack and pinions are used. Next is the next terminologies of the gear. As I shown the terminology thing, the base circle, pitch circle, addendum gear, dedendum, all the things are very very important. I am going to share some of the important terminologies available in the gear. First one, the pitch circle. The pitch circle is very very important because the size of the gear is specified by means of the pitch circle diameter. If we want to say, if you go to a shop and you want to buy a gear drive, you have to specify the pitch circle diameter. If I said 100 diameter gear, if I want to buy a 100 diameter gear, then the 100 is called as a pitch circle. Generally, the gears are specified by means of the pitch circle and the cam are specified by means of a base circle. Next one, the pressure angle is very very important because the gears are working according to the law of gearing. In the law of gearing, the pressure angle is very very important because both mating gears, the pressure angle should be common. Then only the gear drive or gear power transmitting is possible. Here, the pressure angle is the angle between common normal to two gear tooth at the point of contact and common tangent to the pitch point. So this is called as a pressure angle. Next is the pitch point. What is the pitch point is, it is a common point of two mating gears. It is a common point of the two mating gears. It's called as a pitch point. If I draw, if this is a one gear and another gear is mating here, this mating point is called as a pitch point. In the pitch point only, the pitch circle of two gears is going to make. Okay, and this pitch point is always having a common normal and a tangent. So this normal and tangent re- represents the law of gearing. That is why the pressure angle and pitch point are very very important. And this is the intersecting point of two pitch circle diameters. Yes, of course, when the two teeth are mating, two opposite teeth are mating, the intersecting point of the two pitch circle diameter is called as a pitch point. Next is the circular pitch. Circular pitch is a PC. It can be denoted by means of a formula pi d by t, where pi d is the circumferential diameter divided by number of teeth will represents the circular pitch. Therefore, we know that d by t ratio is called as a d by t is called as a module. Therefore, pi into m we can get as a circular pitch, where diametrical pitch is the inverse of the module. Diametrical pitch is the inverse of the module. Here we will get a three different kinds of possibilities, which is when diametrical pitch is the reciprocal of diametrical pitch, that is pd is the reciprocal of 1 by m, because from the formula the t by d ratio is called as a pitch circle diameter. For the module it is d by t. It is just an inverse. Diametrical pitch is the inverse. And the next concept is the product of module and diametrical pitch. The product of module and diametrical pitch, I say pd, which is equal to 1. How? Because we have a module of d by t ratio and diametrical pitch of t by d ratio. Therefore, get cancelled and you will get the product of module and pitch circle, or diametrical pitch is equal to 1. What happens if the product of circular pitch and the diametrical pitch, that is product of circular pitch into product of diametrical pitch, We have a pitch circle, circular pitch of pi into d by t, where diametrical pitch is t by d. If we get cancelled, what happen? It is becomes pi. Therefore, the product of circular pitch and the diametrical pitch is pi. So this is the relation we have derived here. We have derived here. Okay. Next one is the law of gearing. So law of gearing, for under better understanding of the law of gearing, this is a single formula is enough for analyzing or realizing the law of gearing. That is d1 by d2. So diametrical pitch circle diameter of gear 1 and gear 2 is the ratio of t1 by t2. How it is coming? So we know that module is the d by t ratio. If we want to compare two gears, then it is very simple. Therefore d1 by d2 is equal to t1 by t2, and therefore the speed will becomes a reciprocal of the teeth, that is n2 by n1. Okay. So this is the law of gearing. Next, gear material. Most of the gear are made up of either a cast iron or alloy steel or a plain carbon steel or phosphorus bronze according to their application. Next is the condition of constant velocity of the toothed wheel. That condition is called as a law of gearing. Law of gearing states that the common normal at the point of contact between a pair of teeth must always pass through the pitch point. So that is called as a law of gearing. So where omega 1 and omega 2, omega 1 by omega 2, which is equal to O2P divided by O1P, that is equal to D2 by D1, that is equal to T2 by T1. Here the O2P is the center of pinion to the pitch point, and O1P is the center of the wheel to the pitch point. We are just making from the center. Next is the velocity of sliding of the tooth. The velocity V is equal to omega 1 plus omega 2 into Q into P, where Vs is the velocity of sliding and at point Q. We have to make a note this: the sliding velocity at the pitch point is equal to 0. The gear wheels, when the gear wheels are mating, the type of motion available in the gears is there is a partial rolling and there is a partial sliding. How means, if we have two teeth are mating like this, if we say where the sliding occurs, say this is the pitch point, at the point of contact in this axis there is a sliding is happen, and this axis rotation is happen. Therefore, all the gear drives are consist of two types of motion. One is a sliding motion and another one is a rotating or rolling motion. So this you have to understand. And next, the type of teeth are in the form of a cycloidal or an involute. In cycloidal teeth, it is not commonly used. The difference which we will get in the forthcoming slides. In the involute gear, mostly we are using in all our applications. Most of our applications, 90% of our applications are using involute gears. And cycloidal gears, only 10% we are using according to the application. So before seeing the form of the tooth, we will have some of the concepts. One is the length of path of contact. Length of path of contact is equal to length of path of approach plus length of path of recess, and the length of arc of contact is equal to length of path of contact divided by cos pi, that is pi is called as a pressure angle, where the contact ratio it is always greater than 1. What I am saying is the if the gears are having in a contact, if this is a one pair, therefore the contact ratio is equal to 1. When there is an another gear is having mating here, so therefore the contact ratio it is always greater than 1. So this is beginning and this is going to be an end. At that point the contact ratio is always greater than 1. The minimum number of pair on the gear tooth in contact, which is called as a contact ratio, that is the contact ratio is the ratio of length of arc of contact divided by circular pitch. And next we are going to see a difference between an involute and cycloidal gear. In the involute gear, first I am going to discuss involute gear and I am going to compare with the cycloidal gear. First, the pressure angle is constant in involute, whereas in the cycloid the pressure angle will varies, it having a maximum pressure angle at the beginning and minimum at the pitch point. And next, path of contact in straight line. Path of contact of an involute is always in the straight line, where in the cycloid path of contact in curved line. Next, in involute we have a more wear, whereas in the cycloid we have a less wear. And the involute gear, the center distance is slightly varying as possible. If we increase the center distance, the pressure angle pi is also increasing. Whereas in the cycloidal gear, there is no possibility of varying the center distance. Therefore, the pressure angle will not vary manually. Here the main problem is the interference. So in involute gear, interference will exist, and cycloidal gear there is no interference exist. In the involute gears, at the tip of one gear to the base of another gear is having a rubbing action, so that is called as an interference. Next, the tooth profile uh, of an involute can be manufactured very easily and the simplest manner, and it is most commonly used profile also, whereas for manufacturing a cycloidal gear it is bit complicated and difficult to manufacture. Here you have an important thing, that in the gear having an involute teeth, the common to the involute is the tangent to the base circle. Therefore, law of gearing is 100% satisfying in the involute gear, whereas in the cycloidal gears it is not possible. Here, for your information, I am going to share some of the system of gear teeth and minimum number of teeth is required in the pinion in order to avoid an interference in an involute gear system. If it is a 14 and half composite gear system, the minimum number of teeth in the pinion should be 12, and if it is a 14 and half full depth involute system, it is required the minimum number of teeth in the pinion is 32. If it is a 20-degree full depth involute system, then the minimum number of teeth on the pinion is 18, whereas 20-degree stub tooth involute system, the minimum number of teeth on the pinion is 14. And next, certain particulars for finding a common value, common design procedure for the 14 and half composite as well as 20-degree full depth involute system, that is the addendum value. From the module only we get an all the design and all the values of the gear terminologies. Here the module is very important, and I am going to add an important point for the mating gear. module of both driver and driven should be same. Then only the power transmission or torque transmission or law of gearing will satisfies. So module is that much important. Module and pitch circle diameter are very important for specifying the gears or a gear drive. First, the addendum of the gear should be one time of module, where addendum is the 1.25 of module. Working depth is equal to 2 module and minimum total depth is 2.25 module, and tooth thickness is 1.571 module, and minimum clearance between the clearance diameter is 0.25 module, and fillet radius on the tooth is zero point 0.4 module. Here the bottom clearance of the part of a spur gear with module 4 can be derived by the bottom clearance is equal to the minimum clearance. The minimum clearance is equal to 0.25 module, therefore 0.25 into 1, that is called as a, if a gear system having 4 module 4 module, the minimum clearance at the bottom or bottom clearance are supposed to be an 1 millimeter. So in this condition can be easily demonstrate how to find the different terminologies by means of a module. If the module is 4, if I want to calculate addendum, means that is addendum is also 4 millimeter, whereas the dedendum, so dedendum is the 5 millimeter, because how it is 1.25 times of 4, therefore 4 into 1.25, that is equal to 5. Working depth that is equal to 2 times of module, therefore 8 millimeter. So total depth is 2.25 module, therefore it is becomes 9 millimeter. Like that we can easily find all the parameters I have mentioned here. And next is the interference. Interference is a main disadvantage as well as the phenomena which will happens in the involute gear system. Okay, here we are going to check the methods to avoid interference. If we avoid an interference in the involute gear, then the gear system will become super duper. Okay, first, what is meant by an interference? An interference is a phenomena when the tip of the tooth undercuts the root of its mating teeth, which is called as interference. That is, a driver gear tooth or tip of the tooth can mess with the driven gear and it will make a undercut in the driven gear. So that is called as an interference. The methods to avoid interference is for making an undercut or reducing the undercutting will reduce the strength of the gear tooth. So undercutting is one possibility, but it can reduce the strength of the gear tooth. Next, by varying center distance. If the center distance is varying, the base circle diameter is constant, pitch circle diameter is constant, and circular pitch is constant. Like that we can vary the center distance. And changing the pressure angle, it is a possibility, and increasing the addendum of the pinion and reducing addendum of the gear, or making stub tooth. So what is meant by a stub tooth? If this is the normal tooth we are using, the stub tooth is the form of the cutted tooth, like that. A smaller tooth, instead of an X here, this is called as an Y. So it is called stub tooth. We are for our necessity we are cutting the gear tooth. Next is the center distance in the mating gear. The center distance is equal to the radius of the gear plus radius of the pinion, where the radius of the pinion is module into thickness divided by radius, and radius of the gear is, sorry, here it is 2. Please change the formula. Here it is 2, where the radius of the gear is module into number of teeth divided by 2. If we add both the things, the module by 2 into capital T minus small t, sorry, capital T plus small t. Capital T indicates number of teeth in gear, and the small t indicates number of teeth in pinion. Next, minimum number of teeth. How to find minimum number of teeth in the pinion of the involute rack system in order to avoid the interference is, we are having a formula, that is T is equal to 2 into AR divided by sine square theta, where the phi or theta is equal to pressure angle, T is the minimum number of teeth, and AR is the addendum of the rack. If this is the formula for the rack and pinion arrangement, for the normal gear, we can say T is approximately is equal to 2 divided by sine square phi. That is, if we have a pressure angle of 20 degree, then the minimum number of teeth is, it should be 18 number of gears. If we substitute instead of pi, we've put in 20, the number of teeth T is approximately equal to 17 point something. Therefore, for the round off value, we are taking it as an 18. And next one is the helical gear, the relationship between circular pitch and normal pitch. The circular pitch PC is equal to Pn divided by cos alpha. So this is for the helical gears. Therefore, pitch circle is equal to normal sub pitch divided by cos alpha, where alpha is the helical angle or helix angle, Pn is the normal pitch, Pc is the circular pitch, where the normal pitch is equal to circular pitch into cos alpha. In the herringbone gear, grooves are present. Grooves are between the helix. Grooves are between helix. Okay. If the number of teeth is increased, the pressure angle will get reduced in the helical gear. And next gear train is the riveted gear train. The riveted and the epicyclic gear train are very, very important. The applications I have given here, the riveted gear train, wall clock gears are manufactured by means of a riveted gear train, and automobile transmission, that is auto gear, lathe tumbler gear, industrial speed reducer, are all by means of riveted gear train. In the epicyclic gear train, it is having a high velocity ratio. All our wrist watches are made up of a epicyclic gear train, and differential gears in the automobile are made up of a epicyclic gear train, and pulley hoist are made up of epicyclic gear train. The epicyclic gear train are the having a capability of self-locking capability, whereas riveted gear trains, both driven and driven shafts are in the coaxial or a same axial. So with this information, I would like to complete my video of the gear and gear drive. If you have any doubt, you can let me know in the comment section. I hope that I have given an enough transformation uh, for the gears and gear drive. Thank you for watching. Thank you all.